Part A asks to show that log r squared x equals 1/2 log rx. It will be helpful in this situation to have the log and exponent properties from the formula booklet. In this case, we're trying to rewrite a log in terms of a different base. This means we can use the last property from the formula booklet. We can rewrite this log as the division of log rx over log r squared. We can use the third logarithm property and rewrite the denominator as 2 times log r. Log base of the base is basically 1, so we get 1/2 log rx. Part B asks to rewrite y in terms of x in this equation. We can use the log identity we just proved in Part A to rewrite log 4x and log 2x to make them in terms of base 2. Using the third log identity, we can rewrite this again as log 2 square root of x. We can then use the second property of logs to rewrite the last two logs in the equation as just one log. We can then transfer the light blue log to the left side to isolate y. The minus sign can be transferred inside of the log by raising the argument to the minus first power. Since both the right and left-hand sides are logs of the same base, we can make the arguments of each log equal to each other. So that's it. The answer would be 1 over square root of 2 times x to the minus first power, or just 1 over x. The region R is bounded by the graph of the function in Part B, the x-axis, and the lines x equals 1 and x equals alpha. The area of this region is square root of 2. We need to find the value of alpha. We can represent this area as the definite integral from 1 to alpha, since these are the x-coordinates. The function we will be integrating is the one from Part B. We have already represented this function in terms of y, so we can just copy down the function in terms of x. We can represent x to the minus 1 as 1 over x and take the constant 1 over square root of 2 out of the integral. And then use the fundamental theorem of calculus by substituting the upper and lower limits into x and subtracting the two values. Since we're trying to solve for alpha, we need to go back to the givens. And since the integral, also known as the area underneath the curve, is equal to square root of 2, we can make this expression equal to square root of 2 and then solve for alpha. So in the end, we get that alpha is e squared. And that's it for this video. Thank you for watching, and I hope I helped you with this question. Please like and subscribe. Bye!